Welcome to The Explainer. Today, we're unraveling a cosmic detective story about a world that absolutely challenges everything we thought we knew about moons. When we think of a moon, we usually picture a silent, kind of dead rock just orbiting a much more interesting, dynamic planet. But way out in the Jovian system, orbiting the gas giant Jupiter, there's a celestial body that completely refuses to play by those rules. We're talking about a world of hidden oceans, ancient craters, and internal dynamos. It's Ganymede.
I really want you to imagine a moon that actually outsizes literal planets. It sounds like a paradox, doesn't it? By definition, a moon is a satellite, right? Just a secondary character in the gravitational dance of a solar system. But Ganymede flips this script entirely. Its sheer size and wildly complex internal engine blur the line between what it means to be a moon and what it means to be a fully fledged planet.
Okay, let's dive into this scale. Check out that staggering figure. 2,634.1 kilometers. That makes Ganymede the single largest and most massive moon in our entire solar system. To put that into perspective, if Ganymede orbited the Sun instead of Jupiter, we would undoubtedly classify it as a planet. It's significantly larger than the dwarf planet Pluto, and it's even larger than the actual planet Mercury. It's just an absolute behemoth.
Part 1. Shattering the Geocentric Universe. Now, Ganymede isn't just physically massive, its historical impact on human understanding is equally colossal. To fully appreciate this giant, we actually have to travel back in time and look at how observing this tiny point of light completely shattered humanity's long-held geocentric view of the cosmos. And the story begins a lot further back than you might think. Chinese astronomical records suggest that around 365 BC, astronomer Ganymede might have actually spotted Ganymede with just his naked eye. But the undeniable turning point? That came on January 7, 1610. Using a primitive refracting telescope, the Italian astronomer Galileo Galilei spotted what he thought were stars near Jupiter. But by tracking them over a few nights, he realized they were moving with Jupiter. This was a literal bombshell. It provided the very first definitive observational proof that celestial bodies could orbit planets other than Earth. For centuries, it was known simply by its Roman numeral designation, Jupiter 3, before the name Ganymede, the mythical cupbearer to the gods, finally took hold in the mid-20th century.
Part 2. A planet-sized anatomy.
So Galileo showed us its orbit, but modern science has peered inside, and what we found is that Ganymede is way more than just a big rock. Notice the stark contrast in the data here between Ganymede and its next-door neighbor, Callisto. They're actually really similar in size and bulk composition, basically equal parts rock and water ice, but their interiors are radically different. Callisto is partially differentiated, meaning it's essentially a giant kind of undifferentiated slush ball of mixed ice and rock. But Ganymede, it's fully differentiated. It has the lowest moment of inertia factor of any solid body in the solar system, clocking in at 0.31. In physics terms, this confirms that all of its heaviest materials sank straight to the center, creating a distinct liquid iron and iron sulfide core surrounded by a rocky silicate mantle topped off with a thick, icy shell. It is built exactly like a terrestrial planet.
And because of that liquid iron core, something extraordinary happens. So the crucial point is this. Ganymede is the absolute only moon in the solar system known to generate its own intrinsic magnetic field. Magnetospheres are almost always reserved for planets, right? Like Earth with our protective magnetic bubble, or giant Jupiter itself. But Ganymede has a hot, convecting liquid iron core that creates an active dynamo, pushing out its very own magnetic shield.
But Ganymede doesn't exist in isolation. It orbits incredibly close to Jupiter. And because Jupiter's magnetic field is so incredibly vast and powerful, Ganymede's personal magnetosphere is actually entirely embedded within Jupiter's massive field. Think of it like a magnetic bubble trapped inside a much larger magnetic bubble. And it's exactly the interaction between these two fields that led scientists to one of the most stunning discoveries of the modern space age.
Part 3. The Magnetic Detective Story. This brings us to a true masterclass in scientific sleuthing. You see, the magnetic field didn't just tell us about Ganymede's core. It inadvertently provided a massive clue to what lies hidden just beneath the moon's frozen crust. Much like Earth, Ganymede's magnetic field funnels charged particles to its poles, creating glowing ribbons of gas called auroras.
Because Ganymede sits inside Jupiter's fluctuating magnetic field, those auroras should rock back and forth dramatically. But when scientists used the Hubble Space Telescope to observe them, they noticed the auroras were barely rocking at all. Why? Because something inside Ganymede was creating a secondary magnetic field that counteracted Jupiter's influence. This magnetic friction cleverly proved the existence of an electrically conductive fluid beneath the surface, in plain English, a massive underground saltwater ocean.
And when I say massive, I mean it completely dwarfs our own planet's water supply. While the deepest point of Earth's ocean, the Mariana Trench, is about 11 kilometers deep, Ganymede's hidden ocean is an estimated 100 kilometers thick. It's buried under roughly 150 kilometers of solid ice. Let that sink in for a second. This single moon likely holds more liquid water than all of the oceans on Earth's surface combined.
But wait, it gets weirder. It might not just be one simple layer of water. Some really fascinating computer models suggest that due to the extreme pressures deep within the moon, water ice can exist in different, highly dense phases. This means Ganymede's interior might actually resemble a club sandwich. Literally, you could have a layer of ice, then a layer of liquid water, then a denser phase of solid ice, followed by another ocean stacked all the way down to the rocky seafloor. And this brilliantly illustrates a dramatic dichotomy on the outside. Notice the two distinct terrains. About a third of the moon is this dark, heavily cratered ancient terrain, dating back some 4 billion years. But then you have these lighter, brighter regions, filled with intricate grooves and ridges. These bright terrains show us that at some point in its history, Ganymede experienced intense tectonic activity, where the icy crust was literally pulled apart, perhaps related to the moon being locked into an orbital resonance with its sister moons, Europa and Io. Part 4. The Search for Life.
So, we have a moon with a geologically active past, a protective magnetic field, and more liquid water than Earth. Naturally, this forces us to pivot to the ultimate astrobiological question. Could this vast, hidden, dark ocean make Ganymede one of the best places in our solar system to search for alien life? Well, the habitability debate around Ganymede is highly nuanced. On the plus side, we know Ganymede has a very thin oxygen atmosphere, created when radiation blasts the icy surface. And if that lowest liquid ocean layer actually touches the rocky mantle, water-rock interactions could absolutely provide the chemical spark for life. However, there are massive hurdles here. If a high-pressure solid ice layer sits at the very bottom, like in our club sandwich model, it would unfortunately seal off the water from those necessary chemical nutrients in the rock. Furthermore, unlike its sister moon Europa, Ganymede lacks obvious signs of hydrothermal vent activity to provide a consistent energy source to warm up the waters.
Part 5. The Robotic Visitors.
Now, everything we've discussed today, the magnetic fields, the club sandwich oceans, the complex geology, none of this is just guesswork. It's the result of incredible engineering feats. Let's move to Europa and see how this builds across the decades. In the 1970s, Pioneer and Voyager gave us our first close-up images, revealing those mysterious grooved terrains. Then, from 1995 to 2003, the Galileo spacecraft actually entered orbit around Jupiter. It was Galileo that made the historic detections of Ganymede's intrinsic magnetic field and gave us the first hints of its subsurface ocean. And most recently, in 2021, the Juno mission performed a close flyby, using its infrared mapper to detect mineral salts and organic compounds right on the icy surface, hinting at what might be bubbling up from below. But we are far from done. The European Space Agency recently launched the JUICE mission, the Jupiter Icy Moons Explorer. It launched in 2023, and after a long, looping journey through the solar system, it'll finally arrive in 2031. After flying by Europa and Callisto, JUICE will do something totally unprecedented. It will enter orbit directly around Ganymede. It'll be the very first spacecraft in human history to orbit a moon other than our own. It's packed with instruments specifically designed to measure the thickness of the ice shell, map the magnetic field in super high definition, and finally determine the exact nature of that hidden ocean.
Ganymede has already transformed our understanding of the universe once, right? Back when Galileo looked through his telescope and realized Earth wasn't the center of everything. Today, it stands as a ridiculously complex, planet-sized world of ice and iron, hiding oceans far larger than our own. So as we wrap up this explainer, I'll leave you with this thought. When the JUICE spacecraft finally fires its thrusters and settles into orbit around Ganymede in 2031, peering through the ice into the dark watery abyss below, what entirely new cosmic rules will this fascinating moon rewrite next? And more importantly, are we looking at the future staging ground for human exploration of the outer solar system?